Today we're talking about function composition. So your essential question is, what is a composition? Well, in math, a composition is when you take a function and you plug it into another function, or you can also plug it into itself. So this is saying that I'm taking f of x and I'm plugging it into whatever g of x is for x. So that's kind of sounds confusing. So let's try some examples and you'll see what I mean. So we have that f of x equals 4x to the negative first, and g of x equals 5x minus 2. So first we have to find the following and state the domain for each answer. So they want us to find f of g of x, which means that I'm taking g of x and I'm plugging it into f. So this means I'm taking 5x minus 2 and I'm plugging it in for x into the f function. So that means that I would get 4 times, and then in place of x I would put 5x minus 2, and then I have all of that to the negative first power. Okay, so remember, I want to simplify this, and if I'm following the order of operations, I do parentheses and then exponents, so I have to do the exponents first. Well, I want to get rid of my negative exponent and make it positive. So to do that, I move it to the opposite side of the fraction. So I'm moving this whole thing down. So then my answer will be 4 over 5x minus 2. Okay? So from there, I'm going to work on my domain. Now remember, when we do domain, we don't just do the answer, we have to do the originals as well. So if I look at this one, this would be the same as like 4 over x, and I can't have 0 in the denominator, otherwise my answer would be undefined. Now I could plug in any number I want for x here, and I would come out with a real answer. So that one would be all real numbers, but this one I can't plug in 0. So that's going to be that way for the entire set that we're working on. We know we can't plug in 0 no matter what, because the original function had that. Okay, so then I can't plug in 0, so I'm going to write that down here. X cannot equal 0, and we'll write it up here too. Okay, and then this one was all real numbers, so we're good with this one. Now, what else, if I look at my answer, can I not plug in for x? Well, if I look at it, I know that the denominator can't equal 0, so that means that 5x minus 2 cannot equal 0. So I'm going to set it equal to 0 so that I can find out what not to plug in for x. So I'm going to add 2 to both sides. This is being crazy. And then I have 5x equals 2, so I divide by 5. So x equals 2/5. So I know that I cannot plug in 2/5 for x also, because then my denominator equals 0. So to write my domain, this one's going to be 3 parts. So I can go all the way up to 0. So I can go from negative infinity to 0, but 0 cannot be included, so I'm going to put a parenthesis around it. And then I can plug in any number from 0 to 2/5, but neither of those numbers can be included, so I have to put parentheses around them. And then I can plug in any number from 2/5 to positive infinity. So this is what it would look like. So I can plug in any number except for 0 or 2/5. So I'm going to write this in interval notation. And so I can go up to 0, but then I can't plug in 0, and I can go between 0 and 2/5, but I can't have 2/5, and then I can go from 2/5 to positive infinity. So that one has kind of a tricky domain. You can also just write all real numbers except x equals 0 and 2/5. So if you wanted to do that, you could do that as well. Okay, let's try g of f of x. So now I'm taking f of x and I'm plugging it in for g. So I'm going to erase this one. Okay, so I'm taking f of x, I'm taking this, and I'm plugging it in for g. Okay, so I have 5 times, and then I would have x, which equals 4x to the negative first minus 2. So if I have 5 times 4x to the negative first, I can multiply these. So that would equal 20x to the negative first minus 2. Now I don't want to have any negative exponents in my answer, so I have to move the x part down to the bottom. Now that's only with the 20, so I'm going to have 20 over x minus 2, and that would be my answer. Now remember, my original domains, I already know I cannot plug in 0 for x. And if I look at my answer, I have x in the denominator again, so I can't plug in 0. So overall, my domain is going to be that x cannot equal 0. So you're going to have from negative infinity to 0. I can't plug in 0, so I'm going to leave it in parentheses, and then from 0 to positive infinity. So this shows that I can plug in any number except 0 because there's parentheses around the zeros. Alright, now let's try f of x. So that seems like it would be weird. So I'm taking f and I'm plugging it into itself. So if I come back up here, let's take a look at that. So that means I'm taking f, 4 times x to the negative first, and I'm plugging it in for the x. So that means that I would have 4, and then where I would have the x originally, I would have 4x to the negative first to the negative first. So that's kind of weird. Now you can work this out a couple of different ways and still get the same answer. So remember, we have to follow the order of operations, so we have to do parentheses and then exponents before we multiply. So there's a couple ways you can do this. You can take all of this to the negative first power. So we would have the 4 in front, and then we'd have 4 to the negative first, and then if I multiply the exponents, I just get x. So I can't have any negative exponents, so this would have to go to the bottom. So I would have 4 times x over 4. So then the 4's would kind of just cancel out, so I just get x as the answer. Okay, so another way you could work it out would be if you take this whole thing and you put it on the bottom first. So then I would have 4 over 4x to the negative first. And then I would have to bring this x up to the top. So I'd have 4x over 4, which still just equals x. So either way, you get the same thing. So you can work it out however you'd like. But basically, if I get x as the answer, I'm using f of x. So remember, I can't plug in 0 because we already decided that this is like 4 over x. So we know x cannot equal 0. But this has no stipulations. I can plug in any number for x and it would just equal any number. So for my domain, all I know is that x cannot equal 0. So it's going to be the same as the last one. I can go from negative infinity to 0. And I can go from 0 to positive infinity. The 0 is not included, so I have parentheses around the zeros to show that you can't plug in 0. Alright. Let's do a few more examples. Alright, so if I have f of x equals 6x plus 3, and g of x equals 2x, they want me to find g of f of negative 2. So this is a little bit different than what we just did on the last one. First, what I have to do is I have to find f of negative 2. Then once I get that answer, I'm going to plug it in to g. So to work out f of negative 2, what that means I'm doing is I'm taking negative 2 and I'm plugging it in for x. So first, I'm going to have 6 times negative 2 plus 3. And I'm going to work this out. So 6 times negative 2 is negative 12 plus 3, which equals negative 9. So I'm going to take that answer and I'm going to plug it into G. So now I have 2 times negative 9, which equals negative 18. And that would be my final answer. So when you have a problem that looks like this, a composition that looks like this with an actual number instead of x, you are always going to get a number as your answer. So you won't have any variables in there. Okay? All right, that's all I have for you guys. So just make sure to go back to the essential question and write your summary.